By now you should be really familiar with how to find the discriminant, what the fuck it even is. B squared minus 4ac, right? And also if you have a quadratic inequality in front of you, as in something x squared plus something x plus a number, bigger than or equal to 0, less than 0, that kind of thing. You know how to solve it. Now we're going to look at why do we even care. We're going to look at, if you have the exam scenario for this, like what do you expect to know? What would you have to think to do without being told? Understand the discriminants. Have you found by now? I mean, think about any number in general. Think common sense. If you're going to find a number, do you agree? True or false? Is it either positive, negative, or equal to 0? Any exceptions? Of course, like a number is either positive, negative, or equal to 0. So if we're doing discriminant, remember discriminant is b squared minus 4ac. It's an actual number we calculate, isn't it? It's a number that you get when you do b squared minus 4ac. So of course that means discriminant is either also going to be positive, negative, or equal to 0. It's just common sense stuff. No confusion? It just means whenever you have a positive discriminant, it means your quadratic equation has two answers. This is just something you need to memorize. For now, just memorize this. Positive means there's two solutions. Negative means there's no answers. And then 0 means one answer. You might be wondering like, okay, yeah, I can memorize positive discriminant two answers, negative discriminant no answers. 0 discriminant means one answer. But I have no idea like what even that is. Like nothing's really come to mind. Like I'm not quite sure how I'm supposed to use this. Check this out. Also, make sure you memorize that solutions and roots is another way of saying answer in the context of this. You might still be confused when you look at this. What I'm saying in general is, take a really basic example. This is, fast forward this part of the video if you already get this first summary. If not, just look at the basic example of 3x plus 2 equals to 0. If x is equal to negative 2 over 3, which you know for a fact is true, but how the fuck did you know this is negative 2 over 3? Because if you do 3 times negative 2 over 3 plus 2, you're indeed going to get 0. You see how that works? Like by definition, we know for a fact this is an example of an answer, isn't it? And how many answers did we get? We got 1. So if you did, like say, x squared minus 5x plus 6 equals to 0, do you get that if you found two possible answers for x, as in x is equal to 2 and x is equal to 3, that just means there are two answers over here. Do you see what I mean by answers? Because sometimes when you're dealing with quadratics, have you noticed when you have a quadratic equal to 0, something x squared plus something number plus a number, if you have the general quadratic equals to 0 type of question, sometimes you don't have two answers for x, do you? Sometimes you have one answer, and sometimes you get your calculator like math error, as in it gives the I thing, right? It gives fucked up answers. You know what I'm talking about over here when you're dealing with quadratics? So what is it telling you? It's telling you, right? If you found two possible numbers over here, it would be what? It's an example saying two solutions, two answers. Another saying two solutions or two roots, if you made that quadratic equals to 0. If you have x is equal to one number, if x was equal to one number only, it's an example of one answer or one solution or one root. And you found out that it's going to be that like I stuff over there, as in the calculator answer made it look really, really fucked up. It just means what? There was no answer to it. There was no solutions or no roots. Okay? That's just all we're focusing on right now here. Just understand what solutions, roots, answers, they all mean the same thing in this context for dealing with exam questions. They're just meaning like numbers that you can replace the x with over here to make the whole thing equal to 0. For a quadratic scenario. Take a look at what this is. I mean, that's just a graph. That's just a quadratic graph. You know, like this is an equation that's going to give you a graph. That makes perfect sense. I'm just saying, look at the graph right now. If you have the graph in front of you, which we do right now, identify how many points it touches the x-axis. Oh, 2. Think about how you would find this if you didn't have the graph. Obviously, if you have the graph, you can just read it off. Oh, when x is equal to 2 and when x is equal to 3. It's going to be y is equal to 0. So the x-intercepts are 2 and 3. Yeah, if you have the graph in front of you, that is. What I'm saying is, if you didn't have the graph in front of you, wouldn't you have to work it out using this? Is this the equation that would allow you to work it out? See what I mean? Because this is the y equation. What's happening at the x-axis? At the intercepts, the y value is equal to 0. So you just make this equation equal to 0. Equals to 0. See how that works? X squared minus 5x plus 6 equals to 0. X squared minus 5x plus 6 equals to 0. Just like that. Bracket, bracket, equals to 0. X minus 2, x minus 3. Now my point is this, okay? We're trying to focus on what? Discriminants. Just say yes or no. This equation, which is this graph, do you agree there's 2 points where it touches the x-axis? Yes or no? Of course. Do you agree that if you made this equation equal to 0, do you agree there's 2 possible numbers that could satisfy the x over here to make it equal to 0? Because it's evidenced by the graph, isn't it? And it's also evidenced by the fact that if you were to do the factorization for that, you'd indeed find 2 answers. Yeah? Yeah? My point is, discriminant, if you were to calculate discriminant over here, what's the discriminant here? Go on, calculate it. Calculate it. It's going to be negative 5 squared minus 4 times this times this. Negative 5 squared is 25 minus 4 times 1 times 6. Is that a positive number? Yes. And what did we say before in the examples? The list? If it's positive, there's 2 solutions. So do you see what we did over here? We know that this graph over here, which has 2 possible intercepts, which has 2 possible answers if you made it equal to 0, 2 possible roots, 2 possible solutions, we didn't actually have to have the graph in front of us, nor did we have to actually solve it like this, nor did we even have to find what numbers of x that make this true. We didn't actually have to solve it, right? We didn't have to find the answer for x to be able to tell how many solutions we get, as long as we looked at the triangle first to see if it was positive, negative, or equal to 0. Because we looked at the triangle first to see if it's positive, negative, or equal to 0, we found out it's positive, we could guarantee we're going to get 2 solutions, aren't we? We're going to get 2 possible answers here if we made it equal to 0 for this quadratic. That's what we care about over here. We care about how discriminant can be used to predict how many solutions there are to something. Take a look at this. Is this quadratic? Yes. As long as it's quadratic, discriminant exists. So discriminant exists. Do you see why we did the practice before? To see if discriminant even exists. You got to know when to even use it, right? Over here, you can tell discriminant definitely does exist. And if you were to calculate it, it would be negative 4 squareds. You would get negative 4 squareds minus 4 times 4 times 0, which is just 16. Triangle is equal to 16. Discriminant is equal to 16. Discriminant is a positive number. Oh, discriminant was a positive number. What does positive number mean? There's 2 solutions. Look over here. If you made this equal to 0, how many answers would you get? You get 2 answers. And how many points do we see on the graph that are the x-intercept? Also 2. Do you see what we're doing over here? 2 roots, 2 solutions, 2 answers. That we knew for a fact we're going to have 2 if we just looked at the triangle is equal to 0, negative, or positive. We knew for a fact it was going to be 2. We don't need to know what the 2 were, but if we wanted to find out whether or not it was going to be 1 solution, 2 solutions, or no solutions, we could tell by doing the discriminant equals 2. Positive number. If we found it's positive number, we guaranteed 2 solutions. Just look like over here. Let's have a look over here. 4x squared minus 4. Discriminant over here is going to be b squared minus 4ac, so it's going to be b squared, well, b is 0. No confusions over there why b is 0, because there's no x over here, b was 0. C is equal to negative 4, a is equal to 4. So b squared, 0 squared minus 4 times 4 times 4, times negative 4, excuse me. And that's what we get. It's still a positive number, isn't it? Minus 4 times 4 times negative 4. Positive number, and what just so happens to be the number of intercepts it has over here? 2. So, how many solutions would we get for this, for x? We also get 2 solutions. We're guaranteed 2 solutions. We're guaranteed 2 answers, 2 roots, 2 solutions. Have a look at this one, okay? B squared minus 4ac. Negative 4 squared minus 4 times a times c. 16 minus 16 equals to 0. Okay, so 16 minus 16 is equal to 0, so b squared minus 4ac is equal to 0. Remember what happens when the b squared minus 4ac is 0? Remember what happens when discriminant is 0? 1 solution. So just look at how many points touches x-axis here then. Also, 1 point. Meaning if we were to make this equal to 0, how many answers would we find for the x? We'd find 1 answer. That's what discriminant is doing over here. See the basic context here? Just like this one over here, b squared minus 4ac, negative 5 squared minus 4 times 2 times 6. This is going to be 25 minus 48. It's a negative number. If it's a negative number, negative 23 over here. Remember what happens when discriminant is negative? It's telling you there's no solutions, which means if you were to make this equal to 0, you'd find that x has no answers. Type that in your calculator. Type it on the best calculator money can buy, the FX901ES. Type it in on the solver. Type in a is equal to 2, b is equal to negative 5, c is equal to 6. What do you get? Do you get a clean number for x? Do you get a fucked up answer involving I? You get a fucked up answer involving I, isn't it? Do you see why that same thing is saying there's no solutions? And do you see, because we found out that the triangle over here was negative, that's also another way of saying there was no solutions over here. Just take a look at this graph also when you plotted it. How many x-intercepts are there? None. It doesn't even touch the x-axis. Take a look at this one, b squared minus 4ac. 0 squared minus 4 times 1. You can tell, just get to the point. It's negative. Negative discriminant. There's no solutions. Meaning if you were to make this equal to 0, you'd have no answers. There's nothing that satisfies it. And here's the proof, because look at the graph. It doesn't even touch the x-axis. Just like this one, I think you get the gist of it. b squared minus 4ac. 0 minus 4 times -1 times -1. That's going to be a negative number. -4, which means discriminant is negative. Discriminant negative means there's no solutions. Meaning if you were to make this equal to 0, you wouldn't get any answers. There's nothing that can satisfy the number over here to make it true. Well, take a look at this. X equals the square root of negative... no, see, fucked up, right? It's math error. See the point? No solutions. Now, here's what it's going to look like for exam scenarios. Four-mark exam question. How could you tell this has got something to do with discriminant? Remember when you can tell whether or not discriminant even exists? It exists when you have a quadratic equals to 0 scenario. My point is this. Take a look at this question. When you have the curve and the straight line, they meet at two distinct points. Because they say the word meet, because you should, without needing to be told, where the question sort of hinting at is you're dealing with intersection. And if you're dealing with intersection, you make one thing equal to another. So your first step should be very obvious. You would have made this equal to another, to the other thing. Because we're talking about meeting at two distinct points. They're talking about intersecting. Intersection is always simultaneous equations. You've got one equation for y, another equation for y. You make them equal to each other. That's how you started off. And you realize over here, isn't this the same thing as -2 over x equals to ax plus 3a? Why is this going to help? Because what happens if you move the x to the other side? You see what we're doing over here? You're supposed to be able to tell that, hey, this thing, this equaling this can turn into something that's, you can sort of see that's quadratic now, isn't it? As in, it turns into a scenario where the discriminant exists. Is the discriminant thing over here? Of course it is now. And you see the point over here? Because if the discriminant exists over here, if you found out that the x over here has two possible numbers, and there's, because remember the x doesn't always have two answers. It can either have two answers, one answer, or no answers for quadratic scenarios. If you found out there's two possible numbers that replace the x over here to make this whole thing true, isn't that the same thing as saying they're going to meet at 2 points? That's very important. Does that make sense to you? If you found two answers to this equation for x, that's proof that you're going to find two distinct points. If you only found one answer, it's going to be 1. So my point is, it's entirely dependent on A right now, which scenario it's going to be, as in 2 points, 1 point, or no point. As in two answers, one answer, or no answers. So they're saying, because you know, what's the relationship that guarantees you're going to have two answers? Triangle being what? Positive. Discriminant being positive. Does the discriminant exist over here? Wouldn't it make sense to calculate discriminant then? Of course. B squared, 9a squared, minus 4 times a times c. That's the triangle. Let's find out what the triangle is. 9a squared minus 8a. Any questions? We found the discriminant for that now, isn't it? As in, we found something that represents the discriminant. Remember the rule that tells you whether or not it's going to have two solutions? It's the triangle being positive. So what's more intuitive than just making that greater than equals greater than 0? Like just making it greater than 0, right? Yeah? Because whenever the triangle is positive just means bigger than 0. Positive doesn't mean anything else other than the fact that it's going to be bigger than 0. And then from here it's just going to be bracket 9a minus 8 bigger than 0. A is equal to 0, or a is equal to 8 over 9. And you see where it's going now. 0, 8 over 9. Do you see why we practiced how to solve quadratic inequalities before? Yeah? Just pick anything less than 0, -1 for example. -1 times -9 minus 8. -9 minus 8 is negative times a negative number, positive. So this is positive. This is positive. You're not confused why we just write it in now at this point. And what are we looking for? We're looking for positive. So these numbers and these numbers. Everything less than 0, everything bigger than 8 over 9. How do we articulate that? Well, a must be less than 0, comma, or a bigger than 8 over 9. That's the answer. Did we pretty much answer the question here? Because they're saying describe the set of values, find the set of values of being, describe what a is allowed to be. All the possible descriptions for a that would make sure that this and this meet at two distinct points. Do you see how the discriminant helped over here? Just like this question over here, for which the line meets the curve. If its line meets the curve, does that mean if you have this straight line over here, because you can tell this straight line, there's going to be a parabola, isn't there two ways it would meet the curve? As in, it can either touch the curve at 1 point or touch the curve at 2 points. And what's the relationship you realize by now? Like, what comes to mind by now when you're dealing with quadratic scenarios? As in, if it's equal to 0, it's going to have one answer. Greater than 0 has two answers. And they're saying in general they want it to touch, meaning in general is the same thing as in general having answers, having numbers that can satisfy x plus 1 equals to x squared plus bx plus 5. Yeah, we're saying like in general, how do we make sure that there's at least one answer basically? At least one answer. It's the same thing as saying triangle is at least bigger than or equal to 0. Because if triangle were equal to 0, if discriminant were equal to 0, you have one solution. If it's bigger than 0, you have two solutions. So do you see in general for it to touch the curve just means either one solution or two solutions? So it just means combining equaling 0 and bigger than 0. So that's why you get bigger than or equal to 0. So that's why you start off the question, because you're still dealing with intersection scenarios, so you make these two equations equal to each other. You have this. You don't even told what it needs to look like before the discriminant can even exist. See what we're doing over here? Move that to the side, you get x squared plus bx minus x plus 5 minus 1. And you see this? Do you see why we did that practice before? Oh, we realize we can still get the discriminant, bracket b minus 1 times x plus 4 equals to 0. And you see where we're going with this. B squared is just b minus 1 squared minus 4 times 1 times 4. That's the triangle. And that's going to be equal to b squared minus 2b plus 1 minus 16. So that's just going to be b squared minus 2b minus 15. Bigger than or equal to 0. Bigger than or equal to 0, isn't it? Calculated that shit? You see what I mean? Once we get to this step, do you see why it was important to do the quadratic inequalities practice? Because it just means you know what to do now. You got the calculator, type it in if you want to, or just do it off the top of your head. 1 equals negative 2 equals negative 15 equals. So 1 equals negative 2 equals negative 15 equals. You get 5 and negative 3, which means b minus 5, b minus plus 3, bigger than 0. Yes? Just like this, pick any number between negative 3 and 5, pick 0, 0 minus 5, 0 plus 3, negative. Oh, okay. This must be positive. What are we looking for? Positive. So, b must be less than or equal to negative 3, or b must be greater than or equal to 5. That's the answer. And we pretty much answer this question here, because look at this. It just means finding the set of values of b just means describe all the numbers that can replace b, or what it's allowed to be, so that you're going to guarantee this straight line in the curve touch at 2 points, or 1 point, as long as they touch in general. Okay? Just look at this exam scenario. By the way, you know when you're watching this video, you're supposed to pause it. By the time we get to exam scenario, you're supposed to pause it and actually see if you can get the correct answer that corresponds to when you unpause the video to see if you get this. Equation of a curve, equation of a line. Does not meet the curve. Pretty easy, right? You already know by now that when dealing with intersection scenarios, they are going to be... Let's just look at the intersection scenario. I'm saying in real time in the exam, you'd say, obviously this is just going to be negative x plus k, y is equal to this. So you make it negative x plus k like this. And you know where we're going with this. As in, we'd realize we can multiply both sides by x, can't we? What happens? 2x squared plus 12 equals to negative x squared plus kx. So it's going to be 3x squared minus kx plus 12 equals to 0. Do you see what I mean? Like we basically turn the intersection into something that definitely has a discriminant exists, doesn't it? And if discriminant exists, what? We're trying to talk for the scenario in which there's no answers. Because that's what it means for it not to meet the curve. No answers. Discriminant less than 0 then, isn't it? How about let's find the discriminant then? If we know it's discriminant less than 0, because discriminant is, it's a scenario here, isn't it? It exists. We're dealing with quadratic equals to 0 scenario. A is 3, b is negative k, c is equal to 12. B squared minus 4ac, k squared minus 4 times 3 times c, right? That's the discriminant. We get discriminant is equals to k squared minus 144. K squared minus 144 less than 0, which is going to be, you can use a calculator if you want to. 1 equals 0 equals negative 144 equals, you get 12 and negative 12, so it's just k plus 12, k minus 12. Any questions about how that's going to be the factorization for your part here? No? Easiest number we pick is just pick this region, pick 0 for example, right? Because you can tell sort of 0 is the easy number to substitute in. You get a negative answer, positive, positive. Ah, beautiful, so our answer is, k must be this region, isn't it? Because we want all the answers that are going to make the whole thing less than 0. So k is going to be bigger than negative 12, less than 12. This is the line, this is the curve. Pretty straightforward. Y is going to be equal to x plus c divided by 4. And you substitute into here, isn't it? For the y squared. X plus c over 4 squared equals to x plus 3. Any questions? Fraction squared is always top and bottom both squared. Like this. So you get x squared plus 2cx plus c squared equals to 16x plus 48. And then you can turn that into, you can tell it's going to be a scenario where it turns into something quadratic, which means discriminant exists. And then once discriminant exists, you know, it's got to be in the correct format first. So there can't be two x's. You've got to have merged them like this, make it really clear what the b is, what the a is, right? What the c is. So you do b squared, which is 2c minus 16, 2c minus 16 squareds, minus 4 times 1 times this, c squared minus 48. That's the discriminant. Simplify that, you get 4c squareds minus 64c, 16 times 16, to get 256, minus 4c squareds. What's negative 4 times negative 48? Get 192 plus 192. See that these can slash out, so you get negative 64 plus 256 plus 90 plus 192, 448. And then dealing with tangent, isn't it? Tangent, doesn't that just mean the straight line and the curve here touches at one point? Oh, one in solution then, one answer, which means discriminant is equal to 0 then, isn't it? And do you see that perfectly allows you to work out the c value? Yes? This question's it's not complete, but I mean, come on, like it's pretty obvious you want to work out what the c value is. You get the drill. When you're watching this video, make sure for the exam question scenarios, because we've got 4 scenarios over here, make sure you pause the beginning, unpause it to see if it corresponds with the solution I put on there afterwards. Press L to fast forward. Press J to rewind. Anything you're stuck on that takes you more than 2 minutes to sort of figure out, message me.